Okay, last example of the day is here. Let me do a little intro here. There are problems with hypothesis test other than the confidence interval just being better. So another example of a problem with hypothesis test is, let's say that you have a significance level of 5%. Sometimes people will land under that 5% just by luck. So a big problem with the hypothesis test is people not publishing experiments with null results. And by null results, I mean that the p-value is bigger than the significance level. So, when people are doing scientific experiments, they want to find interesting results. They want to find results that people didn't know about before. So if they think, oh, I wonder if this chemical would behave differently if I did this thing. They run their experiment, they run a hypothesis test, and they didn't find evidence that the interesting behavior happened. So they said well, I guess that didn't work. And they just sort of don't publish it. The problem is that if they're using a significance level of 5%, then 5% of the time that experiment is going to look like it worked just by luck. So if the people who don't get it don't publish, and the people who do get the experiment to work do publish, well, they didn't really discover anything. They were just the lucky one. So it's like when someone runs an experiment, basically people have to do follow-up experiments to see if it happens repeatedly. Because if it was just luck, then when you repeat the experiment, you'll see that actually most of the time it fails, and they just lucked into the significance level. So it's important for the scientific community to do follow-up experiments to verify that results weren't just luck. But it's worse than that, because when someone publishes some crazy result, like some miracle drug that cures some disease or something like that, before the scientific community has a chance to perform the follow-up experiments, the media gets a hold of it and talks about it. And then people hear about the new surprising scientific result. They don't get as much, there isn't as much press for when that result is later debunked as having just been probability luck. So people hear about this, it gets in their head. They don't hear later that it turns out that the result was just luck, and then it perpetuates myths about stuff that work and stuff that don't work. So it would be even better. Okay, so let me say that, how would I write this? It's important for the scientific community to do follow-up experiments, but by then the media has spread the word. It would be better if people published the null results too. Okay, because if other people have tried that experiment and found that there isn't strong evidence of the interesting behavior, there wouldn't have to be a follow-up experiments. We would already know. So there's sort of some pressure on scientists who do a lot of this type of statistics to publish all of the results, and there's pressure on the journals to publish those results for them. Maybe it doesn't get in as fancy a journal, but they should get out there. The word should be in the public record. So I have an example for this, and it's not specifically about fake results spreading around, and then the scientific community doesn't have a chance to debunk them before they enter the public consciousness. But it's based off of the same idea. So this example is something called the Baltimore stockbroker scam. So this is a real scam that unscrupulous folks sometimes run. So how does it work? So let's say that you are a target of this scam. So you receive an unsolicited letter from a stockbroker. And the letter has a tip that a stock will go up. And so you actually read the letter and you look at the stock, and sure enough, its prediction comes true. So the prediction turns out to be true. Okay. Then the next week, another letter comes with another tip. So now the first one was right, so you're intrigued. So you sort of watch the next couple days, the stock market, to see what happens. And again, the tip is correct. And for the purposes of this example, let's assume that every stock price is either going to go up or down. I'm sort of, to simplify the problem, I'm sort of ignoring the possibility that it doesn't really change, which is of course possible. So we're going to assume that every stock is going to go up or down. The letters from this stockbroker made a prediction about a particular stock and whether it would go up or down, and both times it was right. This happens 10 times. So this happens a total of 10 times. So 10 times you got letters, 10 times the prediction was correct. So 10 times in a row, it was never wrong. Then the stockbroker invites you to invest money with them. Okay, so is this stockbroker a genius investor? And investing with them is a great idea because they obviously have some secret to how stock prices work that's very effective. Well, no. In this particular example, we're going to say it turns out that they just mailed, like the way this works is they just sent out a ton of letters. Okay, so it turns out that this particular scam artist sent out 100,000 letters to start. Okay, because if there's only 2 outcomes for each of these stocks, they have a half chance just by luck of being right each time. Okay, so what are the chances that they're right 10 times in a row? Well, that's 2 to the power 10. And so what's 2 to the power 10? 2 times 2 times 2 times 2 times 2 is 32, times 32 is 1,024. So just by luck, there is a 1 out of 1,024 chance to be correct 10 times in a row. And they're not going on luck. Out of these 100,000 letters, half of them said up and half of them said down. Okay, so 50,000 people got the letter with the correct tip. The ones who got the wrong tip, the scam artist doesn't bother contacting them again. They're not the target. The people who got the right tip get another letter. Half of them get up and half of them get down. And then the half that get up, they're still in the game. The others, the scam artist doesn't bother with them. So 1 out of 1,024. So what's 100,000 divided by 1,024? That is about 97. So 100,000 divided by 1024 is about 97. So out of those 100,000 people, there's an unlucky 97 people that ended up getting the correct tip 10 times in a row. Those 97 people, if they had been reading these letters and believe that somehow it's magical stock picking ability that led to 10 in a row, they might fall for the scam and give some money to this con artist. But actually, it was just volume. And, so I set this up with letters because that's the old story. But nowadays, like with robocalls and email bots and stuff, you can send out millions and millions of these and collect a lot more than 97 potential victims. And there's no probability, like there's no luck in this at all. It's just the fact that like sometimes it comes out 10 times in a row. And if you try 100,000 times, it's going to come out 10 times in a row about 100 times. And the scam artist here is just playing the odds. Okay, so that's basically the same thing that I'm talking about with the problem with hypothesis tests up here. So when I say the problem with hypothesis tests is if there's something that's being studied and a lot of people are running experiments on it, eventually some people are going to get the result just because there's a chance that the result would come out that way by luck. And the only way that we could fight against that is if all the people who didn't get the result publish, right? No one would fall for this scam if they knew about all the other people receiving letters that got the wrong tip. The only reason that this 10 in a row thing seems special is because that's the only one you hear about. You didn't hear about all of the people who got the wrong answers. If you knew they were out there, you would realize that it's total garbage. Okay, so what's the point of this? Well, the point of this is that statistics needs to be taken with a grain of salt. It's all based off of random experiments, and when an experiment shows something promising, it's not proof, you don't know, it's just evidence. You need more evidence to be more sure, and you shouldn't sort of commit irretrievable resources until you're very, very sure, which means running follow-up experiments, double checking things, being careful. All science that's based off of experiment statistics and theory, has to be approached with an open mind, taken with a grain of salt, and it's interesting that there's evidence, but it might be false. All right, so I think that's enough for today, and we'll start a new section tomorrow.